Hey guys, I'm Ashish, and in this video I'm going to solve the fourth question of our maths and some video assessment. So the question there's a non-homogeneous ODE given to us, which is y double dash plus 9y equals cosecant x, and they've asked us to solve this in either two methods. One is variation of parameters and the other is undetermined coefficients. I'm solving this using variation of parameters. So let's get started. Basically, we'll get the general formula of this kind of ODE, which is y double dash plus p of x y dash plus q of x y equals r of x. Okay, so here we can see that our p of x is 0, q of x is 9, and r of x is cosecant x. Y double dash is 1. Okay, so now this kind of ODE has a combined solution, which is a homogeneous solution and a particular solution. So for homogeneous, first let us solve the homogeneous solution. For that, we'll need to write this equation. We need to equate it to 0 because homogeneous solution doesn't have r of x. Okay, so first let us consider the auxiliary equation. Okay, so lambda square minus 3i whole square equals 0. So our lambda will be plus or minus 3i. So basically lambda is of the form a plus or minus ib. Here our a is 0 and b is 3. And homogeneous solution can be written as c1y1 plus c2y2. Okay, so our y1 is our y1 can be written as e power ax into cos bx, which will be a0, so that will be 1, so it is cos 3x. Y2 is e power ax sin bx equals sin 3x. Okay, so this is our y1 y2. So we'll have the homogeneous solution, which is c1 cos 3x plus c2 sin 3x. Okay, now so we've got our homogeneous solution. Now let us do for the particular solution. Okay, so for particular solution we can use a formula minus y1 integration to rx. This is Wronskian value. I'll talk about it after this. X dx divided by w. Now Wronskian's value can be taken by the determinant value of this y1 dash and y2 dash, which is cos 3x sin 3x. This will have minus 3 sin 3x. This is 3 cos 3x. Okay, now we'll have 3 cos square 3x plus 3 sin square 3x. We know cos square plus sin square equals 1, so Wronskian value is 3. Now let's substitute the values and write it. We'll have minus cos 3x integrated y2 is sin 3x. Our r of x is cosecant x, so cosecant x plus, this divided by 3. Next is sin 3x integration cos 3x cosecant x divided by 3. Okay, now let us take this integral as I1 and this as I2. Okay, now let us solve I1 first. Take this 3 outside and just simply solve it. And first of all, I'd like to write the formulas of sine 3x is 3 sine x minus 4 sine cube x. For cos 3x it is, I'll write it down here, 4 cos cube x minus 3 cos x. Okay, so let's continue. Our I1 is the integration of sine 3x into cosecant x. Okay, sine 3x we know, we can write it as 3 sine x minus 4 sine cube x, and we can write cosecant as 1 by sine x. So this whole thing is dx over here. Okay, now so this will become 3 minus 4 sine square x dx. Now for sine square x, we can write sine square x as 1 minus cos 2x divided by 2. Okay, and similarly for cos square x, it is cos 2x plus 1 by 2. Okay, yeah, it will be useful later. So yeah, this is it. Now we have 3 minus 4 into 1 minus cos 2x divided by 2 dx, and this will become 2, so it is 3 minus 2 plus 2 cos 2x dx. So 2 3 minus 2 is 1, so we'll have here x plus 2 integration of cos 2x dx. Integration of cos x is sin x, so it will be 2 into sine 2x by 2. This and this will get cancelled, so our first integration value is x plus sine 2x. Let us solve I2 now. Our I2 is cos 3x into cosecant x. Okay, our I2 is cos 3x into cosecant x. So the value of cos 3x is, the formula for cos 3x is 4 cos cube x minus 3 cos x. Okay, and this thing into 1 by we can write it 1 by sine x. Okay, dx. Now multiply it inside, you'll have 4 cos square x cot x minus 3 cot x dx. Now we know the formula for 2 cos square x, so we can write 2 into cos 2x plus 1. Formula for cos 2x we know is 1 plus, 2 cos square x minus 1. So if it goes there, go like this. Okay, now this into cot x minus 3 cot x dx. Okay, totally into dx. Now again 2 cos 2x plus 2 cot x minus 3 cot x dx. So we know the, oh no, wait a minute, I did a mistake here, sorry. We need to multiply this into cot x again. So what I'll do is we have 2 cos 2x plus 2. Okay, now this whole thing should be multiplied into cot x again minus 3 cot x dx. So now this is 2 cos 2x cot x plus 2 cot x minus 3 cot x dx. Now this will become minus, so 2 cos 2x cot x minus cot x dx. Now we should take cot x common. I mean, all of this is integration. First of all, we'll take cot x common. So cot x into 2 cos 2x minus 1 dx. Now we can consider the formula cos 2x equals 1 minus 2 sine square x over here, and if you write it it will become cot x into 2 into cos 2x, so 2 minus 4 sine square x minus 1 dx. So this will be 2 minus 1, so it will be cot x minus 4 sin x cos x, because cot x is cos by sine, so sine and sine will get cancelled over here, so it will have this thing. Okay, so cot x can be written as cos x by sin x. We'll integrate them separately. 4 into sin x cos x dx. Okay, now in this first case we will take sin x as t, then you'll have cos x dx equals dt. So you will have you can write this as integration of 1 by t dt, whereas over here this is for the first one. Let this be first and let this be second. For second one, if you take sin x as u, then cos x dx equals du. Okay, so this will be 4 into t dt, and u du. Okay, this is ln t minus 4 into u square by 2. This 2 can cancel. So here our t is nothing but sin x and u is nothing but sin x again. So we can write ln sin x minus 2 into sin square x. So now our yp is cos 3x by 3 into, what is our I1 value over here, x plus sin 2x. So cos 3x by 3 into x plus sin 2x, which is, this is minus, sorry, I hope I didn't make a mistake over there. Yeah, okay, cos 3x, correct. So yeah, and our next thing is plus sin 3x divided by 3 into ln sin x minus 2 sin square x. This is our yp. So our final solution is nothing but yh plus yp. So I don't think it will fit here, I'll write it here. So our yh is, I'll show it to you. Yh is c1 cos 3x plus c2 sin 3x. So c1 cos 3x plus c2 sin 3x plus our yp is minus cos 3x by 3 into x plus sin 2x and plus sin 3x by 3 into ln sin x minus 2 sin square x. Let's just check what I did now. This is the answer. the solution for the ODE. First we did this in, we found the auxiliary, we took the auxiliary equation and did this, and we got yp is the main thing. So yeah, correct. And okay, yeah, so our y is, our solution is c1 cos 3x plus c2 sin 3x minus cos 3x by 3 into x plus sin 2x plus sin 3x by 3 into ln of sin x minus 2 sin square x. Thank you. Hope you understood.